here's an example, our first example, of graphing a log function. So they want us to graph on this graph here a log function. So let me help with this. What do log functions look like first off? So when you graph y equals log base b of x plus a, I'm going to call it. I'm going to give you like a general rule here. The first thing to know is the opposite negative a, opposite of the number next to x, negative a, is the vertical asymptote. So log graphs always have a vertical asymptote, and they have that at the opposite of their number that's next to it. So they'll have it, so let's say back here at negative a, opposite, and then from there, generally, the log graph does something like this. It's the general. Now they can flip them and do all kinds of fancy stuff with them, but that's generally what a log graph looks like. Okay, let's get into the specifics of our function. So we specifically have, come down here, y equals log base 3 of x. So notice we don't have any number inside the parentheses with x, which means we really have plus 0, don't we? Right? Do you see why that is? If I made that x plus 1, that you can't do that. That's different. X plus 1 is certainly different than x alone, but x plus 0 is the same as x alone, so there's really a plus 0 in there, and that means that our vertical asymptote, which is what this is 0. Okay, and let's see it. Let's just make a table. I think that'll be the easiest way to see everything. I'm just going to make an xy table here. I'm just going to start by plugging in 0, and we get log base 3 of 0. Now, you don't have a log base 3 button on your calculator, so how are you going to do this? Well, you go log 0 over log 3, which will give you error, by the way, because this is the vertical asymptote. But I want to explain what I just did there also. So, and let me write the rule in general right here. When you have log base b of w, let's say, you just set it equal. It's equal to log w over log b. In other words, you make it into 2 logs. You make it 2 logs, and the base goes to the bottom. See how the base is the bottom log there? And that makes sense, right? Base, we call it the base because it's lowered down, like the base of a table is the bottom of the table. So the log base always goes to the bottom. So that's how you do weird logs like log 3. You don't have a log base 3 button on your calculator, so you make it into 2 logs. The base one goes to the bottom. Hit the buttons on your calculator. Now we already said log is 0. You can't do that. That's an error, which means that's where the vertical asymptote is. That's why I'm writing VA here. It means vertical asymptote because we got an error. That's what that error is telling us. The inside of the log can't be 0. Remember we said that right here. 0 is our vertical asymptote, right? The number next to x, the opposite of that number, the opposite of the number next to x is your vertical asymptote. Why? Because if you plug in negative a there for x, negative a plus a is 0. It makes the inside of the log 0. And if you and we can see right here, the inside of the log 0 is an error. That's where the vertical asymptote is. So, long story short, maybe that long story was already long, but it's the vertical asymptote's going to be right here at 0. Now, they're not asking me for the vertical asymptote, so that was no extra charge, but I better move on and find what they do want. What do they want? I'm going to plug in another point. They want the rest of the graph, so I'm going to plug in log base 3 of 1 now, y equals. And what's that? Well, you got to make it into 2 logs, right? And the base goes to the bottom, right? Base to the bottom. Hit the buttons on your calculator, you get 0. So that's over 1, up 0. That's right here. I don't know if you can see. This is negative 1, 0, 1, 2. And so this is the point over 0. No, it's not. It's over 1 up 0. What am I doing? Over 1 up 0. Okay. Now we need, then that's the point on the horizontal intercept. We plotted the horizontal intercept, right? That's on the horizontal axis, the x-axis, isn't it? So we've got the horizontal intercept. Now we need one more point. So now just go up to 2, say. I'm just going to try that, see what happens. So y equals log base 3 of 2. How do we do that? Use your calculator, remember. Whoops. Make it into 2 logs. The base goes to the bottom. I'm going to hit the buttons on my calculator as well, because it's a weird decimal number. I don't know. It's 0.6, 0.63, blah, blah, blah. I'll just say 0.6. So over 2 up 0.6, it's about right there. Now, that's a valid point, except the graphing tool is not going to let you choose a decimal location. So instead, I gotta go on up another one. Let's go to 3. So y equals log base 3 of 3. Make that 2 logs. The base goes to the bottom. You can hit the buttons on your calculator, but can't you just tell it's going to be 1? It's the same thing over itself. So over 3 up 1. So there now is our log graph. It looks like that. Yeah, so if you put in this point and this point, you click those 2 points, the graphing tool will make the log graph, and there it is. See how the graph is getting close to the vertical asymptote line, which is a guideline for it, and which is 0 because that's what makes the inside of the log 0 is just simply x equals 0. That's the opposite of the number next to x. There's no number next to x, so the vertical asymptote is 0. See, the graph is guided by that. Now, in your example, you might have something like log base 5. So what you should do is go all the way to 5. When you plug that in, you'll get 1. See, when you just go up the line and you'll see if you had log base 5 of x and you plugged in, let's make it over here, and you plugged in 5, then you would get log base 5 of 5, make it 2 logs, the base goes to the bottom, and that's 1. So whatever your base, plug in that same x value. See, the base matches the x value, and you'll get 1, and you'll get your other dot. So there we go. There's the basics of how you graph a log.